This is section 10.1, and we start off with the definition of a function. A function is a special relation of numbers where each x is paired with exactly one y, and that's the key, exactly one y. So here in this chart is a little bit about function notation. Instead of y, you often see f of x. Y equals f of x. X is the input, the f is just the name of the function, and y is the output. Okay? It does talk about that the input values are domain and the output values are range. We could look at this diagram and decide whether it is a function or not. We simply have some x values and some y values. This one is actually not a function because 28 right here is paired with 27 and with 19. So your clue if you're looking at a map is to say, is there any number that has two lines coming out of it? If it does, that would fail to be a function. Here we have a list of numbers. Is this representative of a function? It's not, because 3 is repeated. It is paired with 8 and with -8, so that fails to be a function. Domain. We're going to hear about domain through this chapter sometimes, and domain is where x can live. There's sometimes restrictions on x, and that would be a rational function or a square root function. So we have to keep that in mind as we decide what the domain is. Have a little caution paragraph here. When finding the domain of a function, there's two operations to avoid: dividing by 0 and taking the square root of a negative number. So just remember those. So we have some examples of finding the domain. Number 1, x squared. And want you to think about, are there any restrictions on this? Is there anything that x couldn't be, that it would not be allowed to be? There's none. The domain then is all reals, or you could write it negative infinity to positive infinity. 2, f of x is the square root of 6 minus x. Well, we know that the square root has to be bigger than 0. So we take this inside part and set it greater than or equal to 0. We can take the square root of 0. We cannot take the square root of a negative number. We then solve this inequality, and if we move x to the other side, if we add x to both sides, we get 6 is greater than or equal to x. Or you could read it x is less than or equal to 6. That's the domain. Every x that is less than or equal to 6 would be okay in this original statement. All right. Now we'll move up just a little bit. F of x equals 2 over x squared minus 9. Remember that we cannot divide by 0. So the only thing that would be a problem in this one is any number that would make that expression go to 0. So take the bottom, set it equal to 0. In this case, we factor it and get x minus 3 and x plus 3. Solve those. You have x equals 3 or x equals minus 3. Those are the restrictions on the domain. So the domain is x not equal to 3, x not equal to -3, or if you had to put it in interval notation, it's from negative infinity up to -3, from -3 to +3, and from 3 to infinity. The vertical line test is something we use when we don't have an equation, we don't have numbers or maps to look at, we just have a graph. You can literally take a vertical line and draw it through your draw it through your graph. If it hits it only one time, it is indeed a function. So here with the straight line, that was fine. The parabola, we drew a straight line. But with the circle, when we draw that same vertical line, we hit it twice, so that fails to be a function. All right, I think that'll give you the main ideas of section 10.1, so let's go ahead and get started on our problems. Number 1, determine whether the correspondence is a function. Well, remember what we said, that your key that you're looking for in things like that is there a number where two arrows are coming out of the same number? And that's not the case. Each x is paired with exactly one y, so that is a function. How about number 2? Is that a function? Look at your x's. Is any of those numbers repeated? No. So yes, this is a function. All right. 2x minus 7, that's just a straight line. Is there anything that's a problem? There's no denominator that we have to worry about. There's no square root. That is all real numbers. And in interval notation, it is from negative infinity to positive infinity. All right, x to the 10th. Is there anything we could let x be to give this a problem? No. So this is all real numbers, or negative infinity to positive infinity. X minus 6 to the 1/2. We need to remember that that is the same as the square root of x minus 6. So we take the inside, set it greater than or equal to 0, solve it, and we get x is greater than or equal to 6. That's the domain. So you can write it this way, or you could do it interval. That's what it asks us to do. Bracket 6, comma, infinity. Number 6 is the same way. We've got to take the bottom and set it equal to 0. So x squared equals 1. X is plus or minus the square root of 1, which is 1. These are your restrictions. So when you're putting that in interval notation, you have b, negative infinity up to negative 1, and excuse me, or negative 1 to 1, or 1 to infinity. We're asked to give the domain and range of the function in this graph. All right, domain is every x that's represented. So the furthest left x we have is negative 7. The furthest right x we have is 9. So, and this one has a closed circle, this has an open circle. That means we're going to have bracket from negative 7 to 9 parentheses. And then we do the same for the range. What's the range? The lowest y value is negative 5. Highest y value is positive 5. So again, here's the way to put that in interval notation. The domain of this, and then use the graph to find various items. So what is the domain? This one is has limits on it. So it starts at negative 2 and it goes to an x value of 4. So that is that one. Okay. What is the range? It starts, the lowest y value is 0, highest is 8, so the range is 0, 8. A part, what's f of negative 2? We go to negative 2 on the x-axis, and we move till we're on the graph. Well, we're already on the graph, so the y value there is 0. F of 0. Go to 0 on the x-axis, move till you're on the curve. What's the y value? 8. F of 1/2. That's right here. We're going to move up till we hit the graph. What's the y value there? 6. What are the values of x for which f of x is 4? Go to 4 on the y-axis. And we're going through here. So the values of x, that means there's 1 at 3, 1 at 1, and 1 at 1. Negative 1, sorry. And so we would put those in with a comma separating their answers. All right. You're given an expression, 4x squared minus 2. Find the following value, f of t plus 1. That means everywhere there's an x, we're going to plug in t plus 1. T plus 1 squared is this here. And we have 4 times that minus 2. So we multiplied 4 times that and subtracted 2. Ultimately, 4 minus 2 is 2, 8t, 4t squared. Number 10, you are deciding if this is a function. You have a picture of it. Vertical line test. Draw it through. See how many times it hit. And it was only once, so it is a function. Number 11, indicate whether the graph specifies a function or not. So on this one, because we've got a picture of it, we're going to draw this vertical line and see how many places it hits. And it does hit it twice, so it fails the vertical line test, and this does not specify a function. And I believe that's all the problems for 7 for 10-1, and that should get you going on that.